ground. You're on 94.9. It is 14 minutes past 4. And, of course, Tuesday afternoon, we've got Creation Ministries International. And this afternoon, we have a very special guest from New Zealand. We have Mark James from CMI. Are you there, Mark?
I am there, Mick. How are you?
Awesome. It's great to have you on this afternoon. I'm doing well. How are you going?
Doing fine, actually. We've had a good spell of very nice weather, so enjoying New Zealand, absolutely.
Oh, wow. Well, up north, they've had a lot of rain, which is sort of coming down here a little tiny bit now, but nothing too bad, which is great news. That cyclone sort of blew itself out before it hit the ground, but still plenty of flooding up north.
Yeah, we've certainly been watching it from over here and keeping you guys in our prayers, that's for sure.
Oh, thank you. Now, Mark, one thing I was hoping to have a chat with you about today was a little black bird. I noticed you had written a story in creation.com and it grabbed my attention. You have this little bird called a Chatham Island black robin, which is a super cool, cute little bird that is endangered. Can you tell us more about it?
Yeah, certainly can, Mick. It's interesting because most people, if you say there's a black robin, they say, black robin? Never heard of it. And it is the only black robin in the world today.
Wow.
And it's endemic to the Chatham Islands, which is the little island group that's off the coast of New Zealand. It's about 800 kilometres, I think, off the coast of the South Island.
Yeah, and it sounds like a really cool bird because it stays really close to you when you go walking through the bush.
Oh yeah, the robins in general. I mean, I've never come across a Chatham Island black robin because I haven't been to the Chatham Islands. But in New Zealand, robins they're wonderful little birds because as you're walking through the bush, if you're disturbing the leaf litter, then these little birds will come in and they'll start to feast on the insects that you're picking up.
Wow.
And they'll come within a few meters of you, which is just amazing. If you stand still, they just about would land on you. That's how confident these little birds are.
Yeah, cute. And I guess it's a bit of a danger to them too, isn't it?
It is. In New Zealand now, the robins are really only found in areas where there's protection. They're not found in the wild, so they're found in the other parks where there's predator-free zones. That's where you find them. Elsewhere in the country, they are pretty much gone completely.
Wow. And danger-wise, they get eaten by other predators.
Yeah, so stoats and other predators will feast on the birds, and more on the eggs, to be honest. But yeah, that's why in these predator-free zones where they keep out all the predators, the stoats, the weasels, these birds can survive, and they do pretty well. Now, this is the general species of robin. This is not the black robin, which is, as I said, is only found on the Chatham Islands.
Yes. Well, the black robin. Tell us about the problems they've had there.
Well, it's interesting because the black robins on the Chatham Islands, the numbers decreased quite dramatically over the years, and they got down to a stage where there was just 5 birds still alive.
Wow.
And that included one breeding pair. So there was 5 birds, one breeding pair, and the 2 birds that were alive were called. The locals, the scientists called them Old Blue and Old Yellow, and that was the mating pair.
Okay. And
so basically this.
Yep.
Basically, the species had got down to two birds that could produce more.
Now that could be a bit of an issue. I've sort of had a look at that story and heard about other animals that have sort of almost become extinct. And when you get down to only a few birds, you've then got family members breeding with each other, and that's not necessarily a good thing, is it?
It's not, no. It's called inbreeding depression. Basically, you get a bottleneck, and the amount of DNA, variation within the DNA is reduced quite significantly because close relatives often have very similar DNA. But this story is quite fascinating because scientists had been trying to build up the numbers of this bird, and they got down to a stage where there was so few of them left. And there was a conservation wildlife service team led by a guy by the name of Don Merton. Don's died in 2011, but he and his team decided on one last-ditch effort to try and save the species. And what they did is that they, when Old Blue, which was a female bird, laid a clutch of eggs, they would take those eggs out of the nest and they would place them with a closely related species. It's a technique called cross-fostering.
Okay.
And what happened was, because those eggs had gone, Old Blue then laid another clutch of eggs. And the first clutch of eggs were were hatched by the closely related species, while Old Blue had her own eggs. And so in doing so, they effectively increased the number of birds that could be hatched.
Yep.
The number of eggs that could be hatched. And in doing so, what they found was they started to increase the number of birds that were available. Now, these birds were still all related, very closely related to Old Blue and Old Yellow, the male, but at least the numbers were increasing.
Yeah, yeah. So what's the chance of, say, another robin? Do you have blue robins?
Blue robins? I don't think so. I think there's robin redbreast, and there's different robins.
Let's say a robin redbreast. Could a robin redbreast breed and all of a sudden a black robin pop out?
No. What I would suggest is, well, you know what? I can't say that for certain, obviously, because I don't know all the birds around the world. But almost certainly the black robins have, over time, their genetics have changed to such a state that they are just able to produce black robins.
Yep.
Now, it's possible, I suppose, that a robin with more genetic variety might be able to produce a black bird, but the only place we know of black robins in the world is on the Chatham Islands.
And so this blackbird with this reduced genetic information couldn't then, for instance, have babies and red robins pop out?
They couldn't, no. That's the one thing that couldn't happen, because they're so genetically isolated, I suppose. And the black robins, it's like with dogs. Today we have Great Danes and we have Chihuahuas. You can't get a Great Dane by mating Chihuahuas together, and you can't get a Chihuahua by mating Great Danes together. The Great Danes have all the genetic information that gives them the big size, but they don't have the genetic information that can give you the small size. And it's the same with the small dogs. They don't have the genetic information to produce the big dogs. And that would be the case here with the black robin, that the genetic information would be very specialized and could only produce the blackbirds.
Wow. So at the end of the day, when we listen to evolutionists, they tell us how one thing turned into another thing, we've never seen that. Scientists have never actually seen that in real life. They've only ever seen this genetic information breaking down. Is that correct?
That is exactly right. What happens basically is a member of a species will go into a particular environment with different conditions, and so when in that particular situation, birds that are well adapted for that environment will survive. But in the process, those birds become isolated from the other species or the other members of the species, and they have less genetic variability within their DNA. And that's why we see all this. The speciation happens. We know it happens, but this speciation is usually the result of a loss of genetic information. It's certainly not the result of mutations creating new information.
Yeah. So a mutation couldn't really add anything to this bird. It's still taking stuff away, isn't it?
Effectively, yes. Now, to say that a mutation couldn't is probably overstating the position. We know that there are mutations within DNA that are almost like they're pre-programmed to help species adapt to various environments. So, it's the random mutations that we find destroy information and do not create new information.
Yeah. And so in the case of these birds interbreeding, there's more chance than it would be one of those random mutations. Is that right?
With these birds interbreeding, if a random mutation did happen, then it's likely that it would be spread through the population fairly rapidly. So it would start to be a concern, yes. But the big teaching lesson, I suppose, learning lesson for us creationists from this is that one of the most often repeated challenges to the Bible is the fact that just one breeding pair of most kinds of air-breathing animals were saved from the floodwaters on Noah's Ark.
Yep.
And this, of course, means that on Noah's Ark there was this extreme population bottleneck. There was 2 of each kind of animal. Mm-hmm. And the evolutionists will say, well, that's a bottleneck. Yep. And if you have a bottleneck like that, then you're going to have major problems going forward because the genetics is reduced down so much that you're going to get inbreeding depression.
Yep.
Now, this the Chatham Island black robin is it's actually a really good example that even 2 birds that are very closely related can, from there, I mean, the Chatham Island black robin population has gone from 5. There's now well over 300 birds.
Oh, wow.
And they're actually doing quite well. So this idea that a bottleneck is going to cause major problems going forward is actually not the case. And you've got to realize that these black robins, the only reason that they were selected is because they were the only 2 left. Wow. Whereas the animals that were on Noah's Ark, God could have because God brought the animals to Noah to be kept alive on Noah's Ark.
Yep.
And he could have very easily selected a pair of each kind that had a lot of genetic variety within their DNA.
Yes.
So this challenge to the history of Noah's Ark is actually this Chatham Island black robin beautifully shows that this problem of the bottleneck is not actually an issue.
Okay, well, it is 27 minutes past 4. We're with Mark James from Creation Ministries International. If you have any questions for Mark, please send them through to our text line 0401 949 949. We are going into a little break right now. We've got Sam Rivera and Capital Kings with Antidotes. We'll have weather and traffic, and we'll come back to Mark fairly shortly. Good afternoon. That was The Young Escape, Love Me Like You. You're on 94.9. It's 24 minutes to 5. And we have Mark James on the line from Creation Ministries International. He's in New Zealand as we speak. And we've been talking about the black robin, which is a little tiny, cute little black bird that's found on the islands around New Zealand. I have noticed here on the creation.com website, it said when a breeding population is substantially reduced in size, it loses variety in the genetic raw material available for future generations. And I was just thinking, and I guess we'll get to this, but Adam and Eve, they probably had stacks and stacks and stacks of, that raw material, and it slowly petered out, and that's why we don't live for 1,000 years anymore. Could that be fair call?
That's a very fair call indeed. And it's one of the questions we often get asked when we have speakers in churches. People will say, okay, so if we all started with Adam and Eve, where did Cain find his wife?
Yeah.
And of course, people sort of look at it and they know that the answer has to be that Cain either married a sister or maybe a niece. Yep. And of course, marrying a sister, we throw our hands up in the air and we say, well, that's terrible. That's incest. That can't possibly be. What is the Bible telling us that incest is okay? But you have to understand why incest is wrong. It's because close relatives, so brothers and sisters, for instance, are likely in today's world to have similar genetic mutations. And we have 2 copies of every chromosome or of every gene. And as long as there's a good copy, then that's the copy that's expressed. But if you get a mutated copy from both parents, then you've got 2 mutated copies, which means that the mutated copy has to be expressed, which is where you get all the bad things. And that's why close relatives marrying and having children is frowned upon today.
Yep.
But that assumes mutations in the DNA. And if you go back to Adam and Eve were created perfect. I mean, the Bible tells us that everything was created very good, which basically means everything was created perfect. Yep. Adam and Eve's DNA would have been created perfect, which means there would have been no mutations in their DNA.
So it happened because of the fall.
Exactly. So they would have been able to have children even after the fall. I mean, the fall was the start of the downhill progress, but straight after the fall, when they had their first children, there would have been very, very few mutations. So close relatives, brothers and sisters, having children would not have been a problem. And we look at it and we say incest is terrible, but it's only considered to be terrible because of the problems that it causes. And the fascinating thing is that right back at the beginning there, Adam and Eve had perfect DNA, so their children could marry and have no problems. But the Bible also gets it right, because at the time of Moses, the law that close relatives should not marry comes into effect. Why is that? Because over the time from Adam through to Moses, or for creation through to Moses, the number of mutations have been building up over time, and it gets to a point where close relatives marrying becomes a problem. So
but there wouldn't have been any scientists around then to have figured that out.
No, and that's, you know what? And Moses was basically transcribing what God was telling him to transcribe. Wow. So it is the Word of God. So God basically, God knows His creation, and Moses just wrote down the law as God gave it to him. And it's scientific. The great thing is, though, that scientifically it is absolutely right. It makes sense. Yeah.
Wow. We got to this through Robbins.
Yes, we did. Hey, there's one more thing I'd want to tell you about the black robin, which is actually quite interesting because it's a cautionary tale, I suppose, about human intervention in these things. Yep. Now, the human intervention with the black robin has saved the species. So human intervention in this case, just amazing. And I take my hat off to the team that did it. They came up with an idea, they put it into practice, and it worked, and it saved the black robin. But they carried that intervention just a little bit further than maybe they should have. And what they noticed is that some of the black robin's females started to lay eggs on the rim of the nest rather than in the center of the nest. They were laying these eggs on the rim of the nest. Because they were on the rim of the nest, the birds weren't sitting on them, which means that these eggs on the rim of the nest didn't hatch. So the scientists thought, well, we need to increase the numbers. So they started pushing these eggs that were on the rim back into the center of the nest, so that these eggs would hatch. The problem is that over the next few years, this rim laying started to increase and increase and increase. And by 1989, they first noticed it in 1984. By 1989, more than 50% of all females were actually laying these rim eggs.
Why?
Because the rim eggs were from birds who had this rim egg problem. And this is where natural selection comes in. Those eggs were on the rim, So they weren't hatching, which means that the rim egg laying problem wasn't being passed on. But by pushing those eggs back into the middle, the offspring of these birds that were laying the rim eggs were surviving, and they were starting to dominate the population.
Wow.
And the scientists realized what they were doing, and they stopped the repositioning in 1989. And by 2011, it had gone from being more than 50% of females laying rim eggs to just 9% of the females laying rim eggs. And so you can see that natural selection basically was working on those rim eggs. They weren't hatching, which means that problem wasn't being passed on. And these scientists they'd stopped this culling effect of natural selection, and in doing so, they meant that this problem was becoming a bigger problem as the number of these eggs were hatching.
Yeah.
And they've actually since discovered that there is a genetic basis to the rim laying, which reduces fitness. And under normal circumstances, the females with the trait incubated less eggs because they didn't incubate the ones on the rim, which meant lower breeding success than females without the trait. And natural selection ensured that the genes for the bad trait were less likely to pass on to future generations.
Wow.
And that's the thing. Natural selection has a culling effect. Natural selection weeds out all the bad stuff, and what's left is the good stuff, the better stuff, not the great stuff, not the perfect stuff, but the better DNA is then passed on to future generations, whereas any problems are weeded out by natural selection.
Wow. So I guess now I'm seeing this picture back at, when Adam and Eve were around, all of the animals and Adam and Eve, they all had perfect DNA. Would have been a sight to see.
Oh, yeah, absolutely. But what you do have to realize too is, we see lots and lots of different species. For instance, with birds, we see lots and lots of different species of birds. But at the time when they were created, God created, he created two of every human being. We don't know whether he created more than one pair of all the other animals and birds.
Oh, wow.
So we can't say. So we can't say there was just two of every kind created. But what we do know is that since the flood, these kinds have spread out around the world, and we see a huge number of different species around the world that wouldn't have been seen at the time of creation.
Wow.
So we see a lot of different toads and frogs, but there probably weren't that many different kinds of frog created at creation.
Yeah.
But we see lots of different species today.
Wow, that's incredible. It is 14 minutes to 5, and unfortunately, it's the end of our time. Mark James from New Zealand, thank you for stepping in for Dr. John, who couldn't make it this week. It was awesome being able to speak with you, and I know we've got you coming up again in a little bit. I don't know exactly when, but I think it's about, the fourth month, 22nd and the 29th, which we're looking forward to already. And then again a little later in the year, I believe. But, that will be awesome. Thank you, Mr. Mark James, for an awesome afternoon.
You are so welcome, Mick, and I'm already looking forward to coming back on again as well.
That's awesome.